I hope everybody can hear me.
We hear you
Let's
really
start
well.
by.
Perfect.
Oh, good. Oh, good. So we're going to talk about the dictionary, which, as you can see, we got to start with a poll question, of course. And the real question is, have you previously used dictionary in your ECL code? Dictionary is a fairly new part of the ECL language. It's only been around for about 5 years now. So the syntax of a dictionary basically you're going to have a data set and a structure, and we'll talk about the syntax as we get into it. But most importantly here, you can see here from the slide that the dictionary declaration defines a unique set of unique records, okay, derived from a data set parameter and indexed by the first field named in the structure, okay? So it will contain one record for each unique value. So you can think of a dictionary as being very similar to an index, but it's done pretty much on the fly. So let's go to where I'm more comfortable, and that's going to be actually looking at the code and talking about this stuff from the code. So you can see here from we've got a nice inline data set here with 10 colors, and the codes that are going to be used to represent each color. And I've defined 3 dictionaries based on that data set. The first one shows that you can have multiple fields in the index in this dictionary, and you can see these are all unique on both fields. They're also unique on each individual field, so I can have 3 dictionaries defined against this. I'm going to have a color to code dictionary and a code to color dictionary. And in both of these, they have payload fields. They have a key field that's color in this case, or code in this case. And you're going to have a payload of the code or the color, so that you use these for mapping. It's a really good way to map things. Now, just because I'm demonstrating this using an inline data set does not mean that you're limited to doing that. You can derive these from real data sets also, or they can be inline. The advantage of an inline data set, though, is if you've got a small fixed number of values that you're going to be working with, is that the index, the dictionary index is going to be generated and built at compile time if the data set, the dictionary is built from constant data. So that can be more efficient. So we've got these dictionaries, and here I'm going to be using them for as a mapping. So I've got a function here that's going to map a code to a color, and it's going to take the code as its one parameter, and I'm going to be simply calling the color, the code color DCT, and I'm going to take that code value that's passed in and use that as the index into the dictionary. And then I want to return the color. So this is the standard objects.property syntax that we use, and the indexing into a set type of syntax that we can use, except that in this case, the index value, it doesn't have to be a number. It can be a constant value, a text value. So we're going to index on the mapping the color to the code. You're going to use the color to code dictionary, which is going to take the color and return you the code. So when I use these guys, I'm going to pass red to this second one here, and it's going to return 2. And for the second one, I'm going to pass 4 using the map, the code to the color, and that's going to return yellow. And we can see this by actually running it. Running on a training cluster, and here we go. And the first one maps the code to the color, gives us 2, and mapping the color to the code to the color, you get yellow. So 2 in yellow. So you can use this for indexing into lookup tables. This is exactly what these things are really meant to be. They're a quick and easy form of lookup, and they're a lot more efficient than doing a lookup join if you've got a small number of records. So the second way we can do here is we can use the in operator, because the dictionary is also implicitly worked with as a set. Let's see here. I've got that. The in operator documentation says that the value set, you're looking for a value that's in that value set. That value set can be a set of values, and it can be a set expression or the set function, or it can be a dictionary. So when I'm using this here, as using the in operator, I want to know, is green in my set of colors? And it is, I believe. Oh yeah, I got green up there. It's 5. So is green in that set of colors, or is 6 in the dictionary using the code to the color dictionary? Both of these is green in the dictionary? Yes, it is. Is 6 in the dictionary? Yes, it is. Let me try running this again, and let's go for 11. Because I know 11's not in there. And is 6 in the dictionary? Tells me now false, because I changed it to 11. Did everybody see that? Sorry. Let me slow down a little bit. You can see the false up there. And I'll change that back to 6 so I don't mess myself up later. Now, you can also use a multiple field key and use a row. So here I've got my color codes dictionary, which remember here is the color codes dictionary, has a multiple field key, color and code. And you can say, you can determine, is the row containing red and 2, using that record of color codes, is that row in that dictionary? Yes or no? And yes, it is. So this is kind of a cool advantage here, that you're looking for an entire row, multiple elements, and you can use that in operator, which is highly optimized. We can also do multiple fields in the payload. So in this case, I've got a record structure with color, code, and a name, and a data set with colors and codes and names. And so I've got a data set dictionary here, which is going to derive that dictionary from the data set. Now this is constant, so this will also be built at compile time. And then my dictionary is going to key on the color and return the data set. So I can say, is red in my data set dictionary? True or false? It should be returned true, because I do have red there. Or I can say, I can pass that dictionary indexed on red and give me the code value, the red code, which would be, in this case, 2. Or give me the red name, and that will be Joe. So let's validate all of these. Is red in the DCT? Yes, it is. What's the red code? It's 2. And what's the red name? It's Sue. Uh-oh. What happened? Oh, it is Sue. There you go. Red is a boy named Sue. Okay, sorry, that's a bad joke, but it's as good as they're going to get. If any of you have been to my classes, you know that you're now required to laugh at all the bad jokes.
We're laughing, Richard, I promise.
Oh, thank you. I appreciate it. I know I can't hear anybody else, but that's fine. I can hear myself talk.
We're laughing with you, Richard.
I appreciate that. Okay, so now you can make a dictionary that's completely inline without without any items in here. You got the blacks, and then like I'm going to key on the unique color names, and I'm going to return the codes, and I'm going to actually have Fred and Sam have the names in there also. And now is red in the inline dictionary? Yes, it is. And give me the red code, and give me the red name, and give me the entire row. So this syntax is quite easy. So is red in the inline dictionary? Yes, it is. What's the red code? It's 2. What's the red name? It's Sue. And show me the whole thing. And for some reason, this isn't showing up in the ECL. I will just simply go to ECL Watch and look at that result. Give me the inline red row, and there's our row. Red, 2, and Sue. So there's a lot of ways that you can use dictionaries. You can use that in operator, and you can just simply return values from the dictionary by simply indexing into that dictionary and specifying the field that you want from the payload. Okay, and so now you can also use dictionaries and past dictionaries as parameters. Here's an example of using them as a parameter. I got a dictionary func that's taking as its parameter a dictionary. That's the structure of the dictionary. I'm going to get past the structure, a dictionary that takes a color as the key field and has a payload of code and name. And I'm calling that DCT. And I'm also taking a key value in here as my function that's passed in as the second parameter to the function. So I'm saying the DCT indexed by whatever key value, give me the name, please. So that when I do this function and pass it my inline DCT, I get white. But if I pass it my dataset DCT, which remember I did that up here, the dataset DCT, they're exactly the same structures. So therefore I can pass either one of them to my function. I'm using different DCTs here, passing different values, and I'm getting just the name, remember. So for white, I get Joe, and for brown, from the other dictionary, I get Seth. Let's make sure. For inline, let's see, what was this called? Past inline, okay. And we're passed in, the past inline DCT gives me Joe, and the past dataset DCT gives me Seth. Okay, so all of these now have so far been done just with inline data. And what I want to show you is that you can use also a dictionary as the parameter to a data set to turn the dictionary into a data set. Because there are some things you can do with a dictionary or a data set, either way, but there are some things that you can't do with the dictionary. For example, here we get, I've got my record structure, color, code, and name. I've got a data set, black, brown, red, white, got a nice data set of that. I'm going to derive a dictionary from that data set, and it's going to have the two fields in there, color and code, as the search terms. And I'm also going to redefine that as a data set from the dictionary, so that we can actually see what's in the dictionary data set. And then we're going to use that in a join. So we can see That's not it. What did I test? Oh, I'm sorry. I skipped something. I'll come back to that in a second then. So I've got my data set dictionary use, and so I got my data set as the dictionary that's been transferred into a data set. And then I've got a join here where I'm joining my data set to my DCT data set where the colors are the same. And that result gives me exactly the same result. Now, I can do this. I can join the data set to a dictionary that's been turned into a data set. But if I do this instead of a data set and try to join it to a dictionary, check my syntax, and I get a syntax error down there. Basically, you can't use a dictionary as either of the left or right data sets for a join, which is why this data set form of turning a dictionary into a data set is very useful. Now let's back up to what I skipped. What we were doing is we've been using inline data sets. Now for this one, I'm actually using a person's file from our training cluster. It's got 841,400 records. Those of you that have come to class, you know exactly what that number is, and you know exactly what this data is. So I'm simply taking the first 1,000 records because if I try to do it on the entire person data set, it will end up with a too big for memory. It won't. It gives me an error when I run it. So just taking the first 1,000 records here, I'm going to have a data set there with 1,000 records in it, and I'm going to take that data set, and I'm going to take the middle name as the key field and the ID as the payload field. Now, watch this really closely because we're going to see here that my person's data set, I've got 1,000 records here, and we can scroll through them all, and you can see that the middle names, all that do have middle names, are just one letter each. Once again, that should be familiar to everybody that's come to class. This data, even though it's a 15-character string, only contains one character at most. So we've got 1,000 records there. And remember, when we talked about the dictionary in the beginning, it's a dictionary always has a unique set of records based on the key field value. So here, my key field is going to be the middle name. And I'm deriving it from this 1,000 record data set. And what you'll find here is when I get done, the DCT only has 27 records in it. And when you sort them by the middle name, you can see we've got blanks, and then we've got all these things indexed and sorted. Now, I took the ID field, and you can see here that the ID field, I've got a lot of different duplicate values of the middle names, and when it did the build of this, it did a dedupe on those middle names. And the ID field that it took was always from the first instance. As you can see here, we've got a middle name of N. That should be the first instance. So that ID ends in 565. And when we go over here and look at the DCT, we find that the N, that ID ends in 565. So any payload fields, when you've got multiple, when you've got a data set with multiple key field values, and you build a dictionary from it, you're only going to get one entry for each unique key field value. And if you are taking payloads from any other fields, that payload will be filled from the first instance that it finds, and that's it. That's the case here with all of them. To the person's data set, there's my first blank, ends in 666, and my blank ends in 666. So that is how the syntax works. Let me share with you just a little bit of information that came to me from a blog that Gavin Halliday wrote in 2014 about one of the things that you can do. And it's a blog about joins, and he's talking about pseudo joins. You can look up this blog. It's on the website. It's on the portal. And he says that you've got an implicit data set lookup happens when you're filtering where a field equals a search value, and then indexing to give you the first one and give you whatever field you want from that guy. When you do this, it's an implicit data set lookup. So if the data set is small, you're better off using dictionary for this kind of thing. That's one of the uses that Gavin is saying is exactly what you want to be doing for dictionary for. Or using that in operator and the set function, looking for for a value that's in a set, and you're filtering by that. If the value is contained in another data set, if the data set is small, the dictionary is going to be a lot more efficient than doing this. Because remember, the set's probably going to be it's a function that's going to build the set of values from that data set based on all the value fields. So if you've got if we were doing a set of those middle names, and out of 1,000 records, hit it. Because set function doesn't do any dedupe, but the dictionary does when it's built. So that's a key thing to remember about the dictionary function. So between these two, filtering the existence, it's like a lookup. It's like an inner join with a keep one. If it's small, the dictionary is going to work. Otherwise, an inner join with a keep one is going to be better than doing this. But the whole point here is that dictionary becomes useful here in this sort of situation. So that's all the basic syntax. So now let's take a look very quickly at a piece of code that came in from a forum post. If you want to look for this forum post, you can search for forum post number 643. That's where this came from. And the problem that we were looking to solve here was to take this string and take fields such as PVT and LTD and replace them, replace PVT with private, replace LTD with limited. So we've got a data set of our data and a data set of our replacements that we want to do. And we're looking for gate, and we're going to replace that with Fred. Now, the first solution that we came up with for this was to do a loop. And this loop does the job. It works perfectly fine. Let me run this and show you the result. And then we'll talk about exactly what that loop code does. As you can see, the solution ends up with Infotech private limited. So the PVTs have been replaced with private, and LTDs were replaced with limited. And of course, that what was it that we were looking for? Gate got replaced with Fred. Okay. So how was that done? Well, with the loop solution, first we get how many records there are in my lookup records. I want to look up values and how many of those, and the number of records in that lookup data set is going to determine the number of iterations that the loop is going to do. So since I have 3 records that I'm looking up here, private, PVT, LTD, and gate, then we're going to do 3 iterations where the body of the loop here is going to each time take the previous result set, starting with the input data set, that's our comprec up there, and passing it to counter. And what we're doing here is taking the entire data set that we passed in and doing a project. So we're projecting through the entire data set, transforming it into my output layout. And we're looking now for my lookup recs. The rec that I'm looking for is which iteration am I on? The first record, the second record, or the third record? That's this counter. This counter here in this scope is going to tell me how many times the loop has iterated. So that's going to tell me that the loop is going to be working with private, or PVT. And it's going to take the company name and do a find and replace in that company name field with the word that it's looking to find and the word that it's looking to replace. In this case, rec.find word will be PVT, rec.replace word will be private. And it will replace all the PVTs with the privates on the first pass. On the second pass through, it's going to take that result set, that's what that rows left means, pass that in as the data set to work with, and it's going to be lookup rec sub 2, and we're going to take the LTD and replace it with limited. Once again, we're going to go look for and find and replace, using the find and replace function to find that LTD and replace it with limited. And as you can see, this works very well. Infotech private, limited, and Fred private. Now, what we're doing with the loop is that if you've got 1,000 different replacement words and you're working on a 10 billion record data set, this loop will project against the entire data set 1,000 times. It's really going to be slow. Therefore, came up with a solution for doing it with a dictionary, which is going to take those lookup recs and create a dictionary where the find word is the index and the replace word is the payload. That's my replacement dictionary. And now I've written a function here that is going to take the string from a single instance of one of those company names, and I'm going to use a record with a variable A string here, and I'm going to take that split words function. The split words function returns a set of values, and it's going to split these words into discrete words, into a set of discrete words, and the space that it's looking for the space. Now, what's getting passed here? Let's talk about it first. I'm going to do my project records where I'm projecting the records that I want to change the data in. So I'm going to do this once. Each record in that is going to do a transform of the layout, and the company name is going to be redefined by the replacement function, which my replace function is going to project through the data set word, through the string, one word at a time, because I'm taking this set of words, using the space as the delimiter between the words, and creating a data set of that. And then I'm going to project through that data set of words. Now, this is going to be a small data set because it's only going to have as many records as there are individual words in this company string, in the company name. So I'm going to project that, and I'm going to transform each record in there, and I'm going to take each individual word and say, if that word is in my dictionary, then I'm going to replace that word. Otherwise, I'm going to leave it alone. So that I get done with I've got a projected data set of all the replacement words, and then I can simply use rollup to take all the individual words with their replacement values, and I'm going to roll that up where the record is true, so therefore I'm going to end up with one record in my rollup because the first record is going to match every other record that comes along. And I'm going to take that record and I'm going to build this original string just like this. My variable length string is going to be taking whatever comes in on the left as the W value, put in a space again, and then take that right word and concatenate it together. Concatenate it all together so that we rebuild the string with the replaced words in there. I want from that rollup, rollup is going to return a record set, therefore I want only the first record in that set, and I really only want just the W value, so that my function here is going to return a variable length string. And very simply, when I do it that way, I end up with exactly the same result. Works with the loop, works with the dictionary, produces the same result, but the dictionary version is going to be much, much, much more efficient, especially as soon as you start talking about working with real-world data and not 3- and 5-record inline data sets. Let's see here. I think I have one more thing that I want to touch on. So a dictionary is like an implicit index. It's built when it's compiled, when the work unit is compiled, if the dictionary is built from constant values. Otherwise, it's built when it's first used. Now, one of the things that we have here available in ECL now is a once workflow service. You can add a once workflow service, and this was added to the language specifically in this instance where we're doing a dictionary, where we're deriving the dictionary from a data set, and we're working on a Roxy query. Because on Roxy, speed is of the essence. And if we're deriving the dictionary from a set of constant values, a constant data set, then the dictionary is going to be built at compile time and everything's fine. But if you're running a Roxy query and you're building this dictionary against a data set that might change periodically, and so the values are going to change, then you're going to want to have that derived from the data set itself, and the once is appropriate for a Roxy query because that will say, I want to build this once for the query and then use the rest of every other iteration. So the first time that Roxy query is used, that dictionary, if it doesn't exist, will get built, and then every other query will go blindingly fast because the dictionary has already been built. And I think that's pretty much what I wanted to talk about here. So let me go back and there we go, back to the slides. So one final question, now that you know a whole lot more about dictionary than you did 20 minutes ago, are you planning to use some dictionary in your ECL code? Thank you. Thank you.
All right, Richard, that was fantastic. And take a moment, go look at the questions from the audience. We have a ton of them, which is great. And a quick shout out, Bob is doing a class, his advanced ECL class today, and I know that he and 7 students, I believe, are watching, so hello. And hopefully some of the questions have come in from that class as well. While you're looking, we're going to take a moment and go to your first poll question. And that question was, have you previously used dictionary in your ECL code? So 87% said no. So I'll be really interested to see the results from the last poll question when those are finished coming in. All right. Actually, interesting already, I'll tell you. Results of the second one that said, will you now use dictionary in your code? 88% say yes. So we've had a good flip there. That's fantastic. All right, Richard, are you ready for some questions?
Oh, sure.
All right, prepare yourself. We have a lot of them. All right, so here's the first one. Can the dictionary key value be a combination of fields?
Absolutely, yes. Let me go back here and go back to this at the beginning. As you can see, this is what we're looking at there is a two-component key, color and code. So yes, the key field values can be multiple fields, and you can have multiple payload fields, although this example doesn't show that.
Right, perfect. So here's our next question. What is the advantage of the dictionary over other techniques?
The advantage of the dictionary is that it is like an index. It's always unique, and it gives you the advantage of indexing, of index use, where indexes, as we know, the whole point of indexing is to make things go faster. So that's the primary advantage.
All right. Fantastic. All right, here's our next question. Is there an online course about dictionary somewhere, or is it included in another one of the online courses?
As of right now, we do not cover dictionary in any of our courses, although Bob and I have talked about expanding the courses and finding a place to fit dictionary in there. As far as an online course right now about dictionary, well, this Tech Talk has been recorded, so you've got one now.
All right, perfect. Thank you very much, Richard. That's a good point. All right, here's the next question. Can you have nested dictionaries, sort of like a JSON structure?
I'm not sure exactly what that would mean. I don't think so.
Okay. So whoever asked that question, if you have additional clarification, you can type that in now and we'll get to it in a few moments, or reach out to Richard directly and maybe he can help clarify for you. All right. So here's the next question. Can a dictionary be used in place of a lookup table?
Absolutely yes. That's exactly what it's for.
All right. Next question is, what's the difference of payload and non-payload dictionary?
Well, it's exactly the same as a payload versus non-payload index. The point being, a non-payload index would probably be used for those instances of merely using the in operator, telling me to determine is there a value in the dictionary for this particular thing that I'm looking for or not. Whereas a payload index, you're actually interested in, is there a value, and can I please see what it maps to?
Okay. All right, here's the next question. Do you have to sort and dedupe your data set before setting it to a dictionary?
As we showed with this example right here, where I had 1,000 records for my person, the 1,000 person records had many duplicates in there, but yet when I established the dictionary on that data set based on the key field middle name, I only ended up with the unique set of middle names. And that was, where was that? The person data set, 1,000 records, but the dictionary only ended up with 27.
All right, perfect. Thank you. Here's another question. Is there a use case where you could use the dictionary function but shouldn't because there's maybe a better way?
And let me go to my notes for that. I asked Gavin in preparation for this particular tech talk a couple of questions myself. One of the questions I asked, is there a recommended maximum size or number of records or a maximum number of key fields or payloads? In other words, how big is too big? And the answer is that there are no obvious limits, but if the dictionaries are large, in other words, if there are a very large number of unique values in there, it's going to be expensive if they need to be distributed to the Thor slave nodes. And and I also asked almost the same question, is there a downside to using dictionary? So the point being here is that when there's very large amounts of data, you should be using an index instead. So if you've got 10,000, 100,000 records, then a dictionary would probably be a really good use. But if you've got 10 million or 10 billion records, then an index is going to be a much better use. And one of the downsides to dictionaries is dictionaries only allow you to do exact matching on the key fields. So if you need to do any other kind of logic, then you're better off using an index instead of a dictionary. In other words, it's no good for ranges, the kind of thing that an index is really good for. Give me all the entries where the income of the person is between 100,000 and 200,000. You can do that with an index, but you can't do that with a dictionary.
Okay. And I think you've kind of answered our last question here, Richard, which is there a recommended maximum size or number of records and maximum number of key fields? Yeah.
Brilliant minds think alike. So we came up with the same question.
All right, guys. Thank you so much. That's wonderful. All right, Richard, that's all the questions that have come in. But we've had so much interest from this audience in actually all of our presenters. So in the deck, we've got contact information, emails for each one of the folks that presented today, and please do feel free to reach out to them. I know for certain Richard and Bob, either one could probably help with dictionary questions. Lily and Atalma could certainly, I'm certain they're both available for additional information as well. So Richard, thank you so much.
You're welcome.